Over the past 18 years, I have been building software products and systems that scale. While AI chatbots are relatively new, really gaining momentum in the last few years, I have seen how proper architecture makes or breaks these projects. Today, we are diving into AI chatbot architecture. Whether you are building your first chatbot MVP or scaling to enterprise level, understanding these architectural patterns will save you months of headaches and potentially your entire project. And trust me, there's a huge difference between a chatbot that users actually want to talk to versus one that makes them immediately reach for the speak to human button. Here is what most people get wrong about chatbots. They think it's just about plugging into ChatGPT or Claude and adding a chat widget to their website. But that's like trying to build a house by just putting walls up without a foundation. In reality, when you go live with this approach, users quickly discover that your bot forgets what they said 2 messages ago, cannot access your actual business data, crashes when multiple people try it simultaneously, and gives responses that have nothing to do with your company or products. The problem isn't the AI model, it's the architecture. A chatbot isn't just a software that talks. It's a complex system that needs to understand context, maintain conversations, integrate into your existing systems, and scale gracefully as usage grows. So let's break down what actually works. A robust AI chatbot is built on 5 core architectural layers. Layer number 1, user interface layer. This handles how users interact with your bot, web widgets, WhatsApp, Slack, Microsoft Teams, even voice interfaces. Each channel has its own requirements and limitations. For voice interactions, you need automatic speech recognition to convert speech to text and text to speech for responses. The key insight here is that your UI layer should be channel agnostic. You want to build your core logic once and adapt it for different platforms, not rebuild everything for each new channel. Layer number 2, natural language understanding. This is where your bot figures out what users actually mean. It does 3 main things. Number 1, tokenization to break down the input. Second, intent classification to understand what the user wants. And third, entity extraction to pull out specific information like dates, names, or product types. For example, when someone says, I want to change my delivery to tomorrow's afternoon, your NLU needs to identify change as the intent, delivery as the entity, and tomorrow afternoon as the new value. Layer number 3, dialogue management. This is the brain of your chatbot. It maintains conversational context, tracks what's been discussed, and decides what to do next. Without proper dialogue management, your bot becomes that annoying person who keeps asking the same questions over and over. State tracking is crucial here. Your bot needs to remember that the user ordered a pizza 3 messages ago when they asked to add extra cheese to my order. Layer number 4, response generation. You have 2 main approaches here. First, template-based responses that are fast and predictable, or dynamic natural language generation that creates more natural contextual replies. Most production systems use a hybrid approach. Templates for critical information and NLG for conversational flow. Layer number 5, backend and integration. This connects everything to your actual business systems. Your CRM, your databases, payment processors, inventory systems. Without solid backend integration, your chatbot is just an expensive FAQ that cannot actually help users accomplish anything meaningful. Let's talk about how this evolves from MVP to enterprise scale, because this progression is critical. For your MVP, use a simplified 3-tier approach. React or Vue.js for the front end, Fast API or Express.js for your back end, and services like OpenAI's API or Dialogflow for natural language understanding. Your database can be PostgreSQL or MongoDB for conversation storage. The MVP timeline looks like this. Week 1 to 2 for core conversation flow, week 3 to 4 for NLP services integration and database setup, weeks 5 to 6 for front-end development, and then week 7 to 8 for user testing and iteration. But even in your MVP, make smart architectural decisions that will not bite you later. Use environment variables for configurations. Implement basic AI versioning. Design your database schema with proper session tracking and containerize with Docker from day one. Now, once you have validated your concept, you need a robust 5-layer production architecture. First, the presentation layer handling multiple channels. Second, API gateway with load balancing. Third, microservices layer with separate services for different functions. Fourth, data and AI service layer. And 5, infrastructure and monitoring layer. The microservices approach is crucial for production. You want separate services for conversation orchestration, NLU, response generation, user management, external integrations, and analytics. This allows independent scaling and much better fault tolerance. Now let us discuss something that is revolutionizing chatbot capabilities. Retrieval-Augmented Generation or RAG. Traditional chatbots are limited by their training data, which creates two problems: knowledge cutoffs and lack of domain-specific information. RAG solves this by combining real-time document retrieval with language model generation. Here is how RAG works. When a user asks a question, you convert it to an embedding vector. Search your knowledge base for relevant documents, retrieve the most relevant passages, and then feed that context to your language model to generate a grounded, accurate response with citations. The RAG architecture includes 4 key components. First, query embedding to convert questions to vectors. Second, similarity search through your document store. Third, context augmentation to combine retrieved information with the query. And fourth, generative response creation using the LLM. For implementation, you need a document ingestion pipeline to process your content, a vector database like Pinecone or Weaviate for similarity search, hybrid search combining semantic and keyword matching, and intelligent context management to optimize token uses. Now, enterprise chatbot architecture introduces additional complexity around security, compliance, and integration. Security becomes paramount. You need web application firewalls, DDoS protections, OAuth 2.0 or SAML integration, VPC deployment with private subnets, service mesh for mutual TLS, comprehensive secrets management, data encryption at rest and in transit, and complete audit logging. Integration complexity explodes at the enterprise scale. Your chatbot needs to connect with CRM systems like Salesforce, ERP platforms like SAP, knowledge management systems like SharePoint, ticketing management systems like Jira, analytics platforms, and communication tools. The architecture pattern I recommend is a GraphQL gateway approach. Single endpoint for multiple data sources, comprehensive rate limiting per user and service, circuit breakers for fault tolerance when external services fail, and multi-level caching strategies. So when you are handling thousands of concurrent conversations, every architectural decision impacts performance. For horizontal scaling, implement container orchestration with Kubernetes. Automated scaling based on traffic patterns, response caching to reduce expensive LLM API calls, and smart routing to send multiple simple queries to faster, cheaper models while reserving premium models for complex requests. Your monitoring strategy needs distributed tracing for request flow visibility across microservices, custom metrics tracking conversation success rates and response times, and proactive alerting for system health issues. For enterprise deployments, consider multi-region active-active configurations, data replication across regions, CDN integrations for global performance, automated backup strategies, infrastructure as code for reproducible deployments, and blue-green deployment patterns for zero downtime updates. Now here is the practical implementation approach that I recommend. First, start with a focused MVP addressing your top 10 most common user queries. Implement basic integration with your primary business system, usually your CRM or support platform. Include human handoff functionality from day one because no chatbot handles 100% of queries perfectly. Your development phases should be 2 to 3 weeks for discovery, 4 to 6 weeks for code development, 2 to 3 weeks for training and testing, and 1 to 2 weeks for deployment and monitoring. Establish your measurement frameworks early. Track operational metrics like usage rates, resolution rates, response times, fallback rates, and human handoff rates. For business impact, measure cost savings, customer satisfaction scores, conversation rates, and ticket deflection rates. Calculate ROI using this formula. Annual financial benefits plus monetized customer experience benefits minus total cost divided by total cost. Well-architected chatbots typically achieve positive ROI within the first year. So building a chatbot that users actually want to engage with requires thoughtful architecture, not just the latest AI model. The key is starting simple with your MVP while designing foundations that can support enterprise requirements as you grow. Remember this progression. Begin with a lean MVP that validates your core use cases. Evolve to a robust production architecture with proper microservices, and scale to enterprise level with security, compliance, and advanced features like RAG. The difference between chatbot success and failure isn't usually the AI technology, it's the architecture that supports it. Start simple, build solid foundations, and scale thoughtfully. What is your biggest challenge with chatbot development? Drop a comment below. I read every one and often turn the best question into future content. If this breakdown helped you understand chatbot architecture better, please hit the subscribe button. I share technical deep dives like this every week based on real-world experience building systems that actually work. Until next time, keep building solutions that matter.